In number 2, we're trying to find that missing side, which is the hypotenuse of that right triangle, and I'm going to do so by using the Pythagorean theorem, which is a squared plus b squared set equal to c squared. C is really the hypotenuse, right? So that's the missing part that we're looking for. If I want to call it c squared, that's fine. If I want to change in, since x is listed as the variable, and call it x squared instead, it doesn't really matter. We know that's the value we're trying to find. The other two sides are 13, so I'm going to call this 13 squared, and then 7. So that's 7 squared. And that's all I'm really doing. I'm just plugging into the Pythagorean theorem and solving for it. So 13 squared is 169. 7 squared is 49. And I'm going to set that equal to the hypotenuse squared, which is x squared, or if you wanted to have called it c squared, that's fine too. Okay, so now when I add these together, I get 218, and that's equal to x squared. Now I need to get x by itself. I don't want x squared, so I'm going to take the square root of that. That's going to allow me to call it just x by itself. And if I take the square root of that, I also need to take the square root of the other side. Okay, so the square root of 218 is what x really is, but then we want to break that down as far as we can as well. When I try to break that down though, you can maybe try to break this down and say, well, that's the square root of 2 times 109. And that's about as far as you get. And we can't really simplify it any further. So we're just going to leave this as the square root of 218. That's the value of that hypotenuse. And if you wanted to plug it into a calculator so you can get an approximation, you could do that as well. But here we're keeping it in our simplest radical form.